Hello, everyone. This is Professor Ma, and this is the introductions on the sections on division, math of divisions. Uh, for numbers, one of the things we did in last chapters is a lot of algebras about polynomials based on we've been able to factor them, factorable polynomials, and then from there we can deduce all kind of things, even can construct graphs. And well, the problems of factorings has to do with divisions. Like for instance, if I ask 156, is this divisible by 6? I mean, we have a method for doing these, the so-called long divisions. And so we divide it by 6 and we scan, not enough. Then we go to 15, say, okay, that is enough for enter the quotient 2. Then we, very important, we subtract. And then after subtract, we carry down the 6. And then we do it again, and 6 times 6, 36, and there's no remainder. Hence, we can say, oh, 156 is has a factor 6 because it divides completely and times the quotients. Okay. We'll do these verbatims for polynomials. And that is, we do exactly, almost exactly the same way, same method of divisions. So, there are two so the way we divide formulas, we call that the long divisions of polynomials. And then from there, there's a short method later on we'll do called synthetic division, which is dividing by a particular very simple forms of polynomial like that, and which will be useful for us later. So let's get into the long divisions. Okay, so suppose I have a polynomial fractions and a dividend and divisors. Okay, and I want to divide them, and I set them up exactly like the same way we want to divide numbers. That is, this goes inside a scaffold, tx, and denominator goes outside. Okay, so we will set up like that. And then just like dividing for number, we will start scanning for quotients. Okay, and the way we do that is we start out with the first term and see what number, what multiply x give me 2x squared, and it's 2x. So we enter the quotient 2x. Then we do the multiplication back into the scaffold and subtract. And this is where the algebra comes in. Okay, if there's anything you have to watch out for, is to watch out these steps. Is after we multiply it back in, we subtract, and the subtract involves changing signs. Okay, and so you can do it this way, you can do it some other way, but I do it this way, just actually do a little sign change on top and then do the additions of 2x minus 2x is 0. And that's the reason for the subtraction. You want to get 0 there, to want to wipe out the wrong terms. Then minus 3x plus 8x, you got 5x. Then you bring down the 4, and you continue. Okay, so, and then you enter the quotient one more time, so you do the same thing, and you subtract one more time, do the sign change, add, and then you finish, and we stop. Why? Because there's nothing multiplied, everything multiplied by x would have had x in here, but there's no more x. Now it's lower than degree x. It's a number. Okay, so this is a procedure for long divisions. And this is what we call it. So the things on top is the quotients. Then what's left over is the remainder. And this is akin to, for instance, if I were to divide 154 divided by 6. And I would go, say, 2 times 6 is 12, and 34. And 5 times 6 is 30, and the remainder is 4. So remainder is here, and the quotient is there. Okay, and what do I say that? Oh, because this is how we put 140 divided by 6 into mixed fractions. The 24, 35, excuse me, goes on top, goes over there. That's the integer part. Okay, and plus what? Plus whatever the remainder is, 4 over what? Over the original. So this is 25 plus 2/3 if you like. So this is the mixed fraction form. Okay. And we can do exactly the same things for the polynomial. That is, we can put this into the mixed fraction form, just like what we did. Okay, the quotient goes there as a formula, plus whatever the remainder is over the original denominator. Oh, it looks like that. Okay. And if I do the fractional additions, put everything into the common denominators, you will see if you do this backward, which is a good practice, if I add this, put everything over x minus 4 and everything together, then do all the algebra, and you want that simplify. It's equal to that. Okay, so the two versions, okay, in proper form if you like, and the mixed form. Okay. So we can do this too. Here's another example. Okay, the only reason we have this example is because if I look at the formula, there's a missing term, x there. When we make the divisions, the scaffold, make sure you provide a space, a parking space for something that's empty, because later on, x will show up underneath. You need a space to park, so you need to put a 0 times x or something there. So here we go. We start dividing, multiply and subtract. Okay, and then enter the quotient one more time, and then subtract one more times and stop. Why? Because the degree is 2 here and degree is 1 here. So there's nothing I can put over here to multiply, make it become x. Well, there's no number I can do that. Okay. No polynomial can do that. Okay. So this is how we write it into the mixed form. Okay. Now, as we said before, if we are dividing by x minus a number of this form, then we have a simpler way of doing this. We call synthetic division. And this one is important because basically what we later on want to check is if we have a polynomial, for instance, does it have a factor x minus 4, blah, 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 times something. And we check this by, we can use, by hand, do synthetic division really fast. And how does synthetic division carry out? Here's how the setup. Okay. You line up all the coefficients, okay, from the highest degree down to the lowest degree. If there's a missing degree, put a 0 there, okay, and put the root, okay. If I'm dividing by x minus 4, set x minus 4 equal to 0, then x equal to 4. You're checking if 4 is a root. So actually, we're checking the number 4 will become a, when we put into number 4 into the formula, the remainder will be left with 0. Okay, the outcome will be 0. So, then the process starts like this. And the first step, bring the first number down. From here is a cycle of the same things. Multiply and put it into next column. Then you add. This is different from synthetic division. Nothing to do with subtraction. You do this procedure, you add. You multiply, you add. 5 times 4. 24 plus 20 is 24. Okay. And this is where the mechanics start. And what does it mean? Okay. And the answer goes backward. The last number is 24 is the remainder. Okay, so it cannot x minus 4 is not going to be a factors. And then the front part is the quotient. You can read it backward. This is how do you read backward? This is the number term, and this is the x terms. And if you have something over here longer, then will be x squared term and so on. In other words, these quotients 2x plus 5. Okay, and the remainder is 24. Or put everything together. This is the big mixed form using the synthetic divisions. Okay, and since synthetic division is used for when things are lengthy, okay, so stick the zeros in there. Check if -2 is a root for this formula, for the formula on top. So you put -2 outside as the divisors. Bring down the first number, then start multiply, add, multiply, add, multiply, add, multiply, add. Boom. The remainder is 0. Okay, and what does that mean? Okay, let's put the answer back. That means the fraction divided by x plus 2 is 1 minus 1 going backward minus 2x, x squared minus 4x squared, 2x cubed. No, wait a minute. 1x squared, x cubed, x4. Okay, and then plus 0. Okay, right? That's a remainder over x plus 2. Let's call, of course, but that's 0, so I don't need that. In other words, if you get a remainder 0, you're going to have what? You're going to have this polynomial is x plus 2 times all these quotients. Okay? In other words, x plus 2 will be a factor. And so this is what synthetic divisions tell us in terms of the relationship between the remainders and whether the divisor is a factor or not of the form x plus. Okay, so this is a usage for synthetic divisions. Do the homework. Okay, bye-bye. Until next time. Bye-bye.